Here are the notes for section 3.1, and then I'll follow this with several examples. So 3.1, beginning of chapter 3, starts with defining complex numbers. I think the title of this section is complex numbers. But before we get to complex numbers, actually, we need to define the imaginary number I. So there's two ways to define I, and you need to remember both of them, actually. So I is defined as the square root of -1, first of all, or we could say that I squared is equal to -1, okay? And what I like to say is you're going to have to know both of those. In section 3.1, mostly you need this one, all right, mostly. However, in the following sections, 3.2, mostly, you're going to need this other one. So you do have to remember both of them to get through this chapter. So what this is used for is being able, it allows you to take the square roots of negative numbers. Previously, you may have thought, well, I could take the square root of 36, and you'd say plus or minus 6. But now, you can take the square root of, let's say, a -36. So my very short little example here would be that, well, we could break that down into this. It's the same as the square root of 36 times -1. Most of you would accept that, I think. And then we could break that apart into the square root of 36 times the square root of -1, okay? Using the previous properties from the first homework assignment. Well, if you accept those steps, then the square root of 36 is just plus or minus 6. And the square root of -1 is I. So the square root of -36, what I'm trying to get at is, this is a long way of saying it, the square root of -36 is plus or minus 6I, okay? And this applies to square roots of other negative values as well. You know, if I asked you to do the square root of -50, you would break that down into the square root of -25 times 2. And the square root of -25 is plus or minus 5I, and that square root of 2 is just left there. Okay, so you're going to have to break down square roots of negative numbers in some of these problems. Not so much in 3.1. This is mostly going to take place in section 3.2. There's a little bit of it in 3.1. That leads into defining complex numbers, which again I think is the title of this section. So complex numbers are of the form a plus bi, or a and b are real numbers. That's just the definition. But more what you're going to have to deal with is stuff like this. This is a complex number. 2 plus 3i is a complex number. -5 minus 7i is a complex number. So what we say is this is the real part of the complex number, the number where the a is, okay, that's called the real part, and then the I part, like in this one, the 3i, that's called the imaginary part. So the imaginary part over here would be the -7i. So that's what a complex number is. And almost all of your answers in this section are going to look like this. In fact, the instructions specifically ask you to write your answers in that form. Okay, but your answers aren't going to have A's and B's in them. Your answers are going to look like this: 2 plus 7i, or 2 plus 3i, or something like that. Okay, I got a couple more rules here, and then I'll get to the examples after this. So one of the definitions you're going to need to know is the conjugate. The conjugate of a plus bi is a minus bi. Really, it is that simple. So if I give you this complex number, let's say -3 plus 6i, the conjugate of that would be negative 3 minus 6i. You notice the only thing that changed about that is the sign in the middle, okay? The conjugate only changes the sign of the imaginary term, okay? So if I gave you negative 1 minus 5i, the conjugate of that would be negative 1 plus 5i, all right? And that leads into the next rule. This is when you're going to have to use conjugates. So when we end up dividing complex numbers, most of this section is just dealing with adding, subtracting, multiplying, and dividing complex numbers. And when we get to dividing, what we really do is we change it into a multiplication problem, okay? And this is the rule. This is just the basic rule, and I'll show you how to do this when we get to the examples in a few minutes. But what we do to divide complex numbers is we multiply both the numerator and the denominator by the conjugate of the denominator. Okay, so that's the basic rule. You have to look at the denominator, and then that will help you decide on your first step. And I'll show you that in the later examples.